Hello, everybody. Thanks so much to Joe, Mark, and the other organisers for inviting me to present today. It's a real pleasure to talk with you all about geothermal energy. It's exciting to see the level of interest in Northern Ireland is very high, and that geothermal energy is being taken so seriously by the UK and Northern Ireland governments. I'd like to share more information from the USA on the latest opportunities for using Earth's heat in the energy transition. The bottom line is that people need to hear more about this energy source and how it can benefit them so positively as we move away from using fossil fuels in our day-to-day lives. I'm the Executive Director of Geothermal Rising. We are the US-based professional and trade association for geothermal energy that advocates and informs for using Earth's heat. We have over 1,200 individual members and 90 corporations with a broad and diverse representation across the geothermal community. We are most well known for the Geothermal Rising Conference, the industry's largest annual gathering. This year, the GRC is in Reno, Nevada in August. Our General Association goals are broad and speak to the hurdles that the community and our members face in deploying geothermal energy. Firstly, we need to raise awareness of geothermal energy among the general public and their governments. Then we need to facilitate innovation of our technologies so that they can be scaled up and deployed to provide energy anywhere and anytime. And finally, we need to work to de-risk geothermal projects so as to encourage greater private investment in deploying our technologies. Over the past few years, we have transitioned Geothermal Rising to be more focused on public and government relations. We renamed and rebranded the organization to Geothermal Rising from Geothermal Resources Council so as to be more approachable and appealing to a broader demographic. We also embarked on developing and executing a marketing campaign that raises awareness of geothermal energy with the goal to trigger a popular movement and create interest among government policymakers and leaders. In April this year, we had our first social media moment that targeted a new demographic for geothermal energy outside of the usual technologists, scientists, and engineers. We used a short video paired with influencers to generate interest, resulting in over 1.1 million views on Instagram and over 300,000 views on Twitter. This is the first of many social moments in our campaign, with each planned to be bigger than the last. As the video illustrates, the really neat thing about Earth's heat is that it's ubiquitous, it's global, it's everywhere below our feet at all times. Geothermal energy is the recovery of that heat that is then converted to electricity or used directly for heating and cooling. I prefer this holistic definition as it encompasses all the technologies. We can use heat from 1 meter below depth for heat pumps that provide heating and cooling to residential properties and businesses, or we can go deeper and use the heat directly for communities, heavy industry, and commercial buildings. Or we can go to thousands of meters depth and use that heat for generating electricity. When we use this holistic definition, then it opens up a conversation about the critical role that Earth's heat should play in decarbonisation and mitigating climate change. In the energy transition, we need to do these 4 things to minimize the impact of climate change and build out an energy ecosystem that will work in practice. We need to electrify everything we can in our daily lives. We need to deliver zero carbon, reliable, and sustainable electricity. We need to optimize the efficiency of all of our energy use. And then we need to develop robust and long-term carbon and energy storage. As we transition to a carbon neutral world over the next few decades, then geothermal energy will play a critical linchpin role. Its 24/7 firm, clean energy source provides reliability, resiliency, sustainability, and efficiency to a power grid that uses intermittent energy sourcing and storage. It will allow our power delivery to efficiently adapt to changing patterns of demand as we electrify everything in our lives, and robustly work through changing weather patterns and extreme weather events. That same firm, clean energy source will provide optimized heating and cooling at different scales, from an individual home to heavy industrial use. The decarbonisation of heating and cooling will allow us to realistically make it to 100% clean and renewable, but we need an integrated and systemic energy policy to make it happen. And as we build the technologies that enable scaling of geothermal energy anywhere at any time, then we also have a huge opportunity to create impactful social and environmental justice due to its widespread ability to provide power and direct heat management. The realization of that linchpin role has led to an acceleration of activity in the US market that includes development and demonstration of new technologies, entrepreneurs and startup companies entering the market, and new partnerships being developed between governments, academia, and industry. The world has about 16 gigawatts of installed geothermal power capacity. The US is the largest producer, with other countries quickly developing easily accessible resources. The greatest developers of power over the past 10 years have been Turkey, Indonesia, Kenya, and New Zealand. On the right here, we see the importance of direct heat use from geothermal energy in our decarbonisation goals. According to the International Energy Agency, the IEA, heating and cooling demand accounts for around half of global final energy consumption. Of this energy, nearly 50% is consumed in industrial processes, while another 46% is used in residential commercial buildings and 4% is used in agriculture. The annual worldwide consumption of energy for heating and cooling of buildings alone is about 84 exajoules, or 84 million terajoules. Of the total final energy consumption for heating and cooling in 2019, the IEA estimates geothermal provided only 0.3%, with all renewables providing about 10%, and fossil fuels about 73%. We have barely scratched the surface, which means there are huge opportunities for growth in clean energy. An estimate of the worldwide installed geothermal heat capacity is about 108 gigawatts thermal, supplying a little over 1 million terajoules of energy, or 1 exajoule. The clean heat equates to a saving of about 78 million tons of carbon per year and an estimated investment of $22 billion across 53 countries. In the US, there is now estimated to be about 1.7 million geothermal heat pumps installed with a 4% growth rate per year. The Department of Energy's GeoVision study, published in 2019, estimated 28 million heat pump installations by 2050 and 17,500 district heating systems. Combined with electricity deployments, that is an estimated $219 billion in domestic expenditures. State policies for renewable power, clean energy, and energy security are driving demand for geothermal electricity generation. This demand will only increase as the overall value proposition of geothermal power, including its end-to-end comparative price, reliability, and environmental footprint, becomes more acknowledged by regulators and utility customers. California is the largest producer of geothermal power in the world. It's also leading the world in becoming 100% clean and is therefore a testbed for how to decarbonize our society. 29 other US states are following in their footsteps. As intermittent renewables like wind and solar penetrate deeper into California power markets, then we are seeing an increasing curtailment of these resources during the day, as shown on the left here, when there's too much power available. There is then sharp demand for power going into the night that's now known as the infamous duck curve on the right. As California decommissions older gas-fired assets and nuclear power, then it needs to find alternative energy sources that provide reliability and stability to the grid. There needs to be sufficient supply during the night, during extreme weather events, and during changing patterns of electricity demand as we transition our energy system. The State Utilities Agency recently issued an order for midterm reliability that includes 1,000 megawatts of new geothermal capacity by 2026, a major incentive to invest and deploy. The energy transition has led to an expanding market for geothermal power in the Western states, based on developing conventional hydrothermal systems that are more easily accessible. Since 2020, there have been 18 power purchase agreements signed. These are long-term agreements to provide power to utilities, creating quality jobs and investment and revenues into communities. 13 of those PPAs provide 468 megawatts of power into California, although a significant proportion of that power is imported from neighboring Nevada. The key to expanding this power generation beyond these western states is to make use of low-hanging fruit at conventional hydrothermal systems in these geological areas of high heat flow, while we innovate technologies needed for unconventional systems like enhanced geothermal systems, EGS, and closed-loop borehole solutions. These technologies give us the opportunity to scale up geothermal power production and expand it across the nation. All we need to do is drill deep enough and we'll access a limitless supply of energy available anywhere and at any time. According to the United States Geological Survey, total accessible EGS resources in the US alone can, in practice, provide much more than 100 gigawatts of power. But geothermal energy isn't just about power generation. It's also about that heat management that can have a large impact on our climate goals. And that heat management can be applied across a broader area right now. Geothermal heat pumps can be installed on any residence, commercial building, or business to replace fossil fuels in heating furnaces and reduce electricity consumption in cooling. As illustrated in the graphic on the top left, the concept of thermal energy networks is to integrate communities and industry into one thermal grid where geothermal heat pumps, direct use of geothermal fluids, and other forms of waste heat recovery are circulated to users and demand centers. This concept provides better management of heating and cooling, greater efficiency of our energy use, and minimizes electricity demand so that electricity generation from renewables can be focused onto other priorities during the energy transition, ensuring the grid can be more stable and robust. To roll out this type of concept, we'll need modern infrastructure being built into our towns and cities that will bring investment and jobs, such as this example in Manhattan, New York. An example of an integrated energy system is the Cornell University campus in New York State. Earth source heat using geothermal fluids will provide 24/7 firm heating as a key component of the university strategy to reach carbon neutrality for its campus of 30,000 people. This focus of heat projects on the northeastern US is not a coincidence. As highlighted in the figure on the left, almost half of the US states have greater than 20% of total statewide energy demand in thermal applications. And in the Northeast, it's nears 40%. As many of these states adopt those total carbon reduction and renewable energy targets, then heating and cooling needs to be part of the equation. At Cornell, the geothermal development includes 2 boreholes drilled to depths greater than 10,000 feet, using traditional drilling technologies from the oil and gas industry. Geothermal resources at the relatively low temperatures for heating are widely accessible across the US, so offer widespread solutions to decarbonization and offer a redirection for existing oil and gas capabilities and workforce. Through partnerships with government and academia, the geothermal industry is developing the technologies to take advantage of the ubiquitous nature of the energy source and expand across the US and internationally. There are also lots of other opportunities for growth where geothermal energy plays well with other technologies, such as co-production of lithium, using abandoned oil and gas wells, solar and wind hybridizations, green hydrogen production, just to name a few. The geothermal industry globally is therefore working together with other industries to build out an ecosystem that successfully uses a mix of resources. When we examine geothermal energy in a holistic manner, then we are looking at a workforce developing into the hundreds of thousands in the US alone, deploying power plants, district and industrial heating systems, and residential heat pumps. This is exciting capacity for new jobs and economic growth in our globalized energy ecosystem. Using the Earth's heat has clearly entered the conversation in Northern Ireland with the meetings today and through this week. I applaud you all for gathering here to embrace that conversation. I would encourage you to look at other areas of the world where geothermal energy projects have been supported, And then deployment has gathered pace with their success and the confidence that success brings for this 24/7 clean and renewable energy supply. Thank you so much for listening.